WiMAX. WiMAX is one of the hottest broadband wireless technologies around today. WiMAX is based on IEEE 802.16 specification, and it is expected to deliver high-quality broadband services. Topics: WiMAX protocol: fixed, mobile WiMAX, WiMAX versus Wi-Fi. About WiMAX. Physical layer. MAC layer. Fixed, mobile WiMAX. WiMAX versus Wi-Fi. WiMAX applications. What is WiMAX? Worldwide interoperability for microwave access. A last-mile broadband wireless access, BWA, alternative to cable modem, digital subscriber line, DSL, or T1/E1 service. Wireless Metropolitan Area Network, WMAN. Based on IEEE 802.16. IEEE 802.16 standards. 802.16.1 to 2001, 10 to 63 GHz, line of sight, up to 134 megabits per second. 802.16.2, minimizing interference between coexisting bands. 802.16a 2003, 2 to 11 GHz, mesh, non-line of sight. 802.16b 2004, 5 to 6 GHz. 802.16c, detailed system profiles. 802.16e-2005, mobile wireless MAN, called mobile WiMAX. 802.16 meters - 2011, data rates of 100 megabits per second mobile and 1 gigabit per second fixed, 4G. 802.16 to 2012, 16p, 16n, current. Standard. Family. Primary use. Radiotech. Downlink, Mbit/s. Uplink, Mbit/s. Notes. WiMAX. 802.16. Mobile Internet. MIMO SOFMA. 128, in 20 MHz bandwidth. 56, in 20 MHz bandwidth. IEEE 802.16 meters expected to offer peak rates of at least 1 gigabit per second fixed speeds and 100 megabits per second to mobile users. LTE. UMTS/GSM. General 4G. OFMA/MIMO/STSA/FDMA. 100, in 20 MHz bandwidth. 50, in 20 MHz bandwidth. LTE Advanced expected to offer peak rates up to 1 gigabit per second fixed speeds and 100 megabits per second to mobile users. Purpose of WiMAX. Providing mobile broadband connectivity across cities and countries through a variety of devices. Providing a wireless alternative to cable and DSL for last-mile broadband access. Providing data, telecommunications, VoIP, and IPTV services. Providing a source of internet connectivity as part of a business continuity plan. Fixed and mobile WiMAX. Fixed WiMAX is optimized for home/office networks. Mobile WiMAX is optimized for mobiles. http://www.connect.com/internetaccess_WiMAX02.htm. Fixed WiMAX architecture. WiMAX as cellular alternative. WiMAX as a mobile voice and data network is potentially exponentially more efficient, profitable, than the legacy cellular infrastructure. WiMAX architecture. MIB, Management Information Base. 802.16 Protocol. 802.16 protocol stack. 802.16 covers data link and physical layer. 802.16 MAC sublayer protocol classes of service. Constant bitrate service. Real-time variable bitrate service. Non-real-time variable bitrate service. Best effort service. Physical layer, PHY. PHY cont. BPSK, 1 bit / baud QPSK, 2 bits / baud CAM16, 4 bits / baud. Example, a 25 MHz bandwidth, QPSK can deliver 50 megabits per second, CAM16 plus 100 megabit per second, CAM64 plus 150 megabit per second. Baud, BD, measure of the symbol rate, the number of distinct symbolic changes, signaling event, made to the transmission medium per second in a digitally modulated signal. 25 BD means that 25 symbols are transmitted per second. PHY cont. TDD, time division duplex. Use same bandwidth for uplink and downlink. Controlled by timing. FDD, frequency division duplex. Use different frequency for uplink and downlink. OFDM, orthogonal frequency division multiplexing. Enhancement of frequency division multiplexing, FDM. Maximize use of bandwidth. Also adaptive antenna support, AS, and MIMO. TDD and FDD. Figure 16.5, frame structure at the physical layer, TDD. In each time slot, a frame is in the air. The base station fills the data to send to substation in the downstream subframe. The substations fill the data to send to the base station in the upstream subframe. How bidirectional communication can be achieved in WiMAX using a frame in following figure 1. Let us assume that WiMAX uses only TDM. Let us assume that WiMAX uses only TDM. In each time slot, a frame is in the air. The base station fills the data to send to substation in the downstream subframe. The substations fill the data to send to the base station in the upstream subframe. Let us give a very simplified example to make the point clear. Assume that the time slot is 1 minute and the communication is instantaneous. This means in each minute there is a frame in the air. 1. During the first half of each minute, the base station is sending data to the substations and the substations are receiving data from the base station, downstream communication. 2. During the second half of each minute, the substations are sending data to the base station and the base station is receiving data from the substations, upstream communication. 16. OFDM uses bandwidth which is not available for use in FDM. WiMAX antennas. Omnidirectional antenna. Omnidirectional antennas are used for point-to-multipoint configurations. Its energy is greatly diffused in broadcasting 360 degrees. This limits its range and ultimately signal strength. Good for situations where there are a lot of subscribers located very close to the base station. Sector antennas focusing the beam in a more focused area. Offers greater range and throughput with less energy. Many operators will use sector antennas to cover a 360-degree service area rather than use an omnidirectional antenna. Panel antennas, a flat panel of about 1 foot square. Often used for point-to-point applications. Frequency plan. By reusing frequencies at different base stations, a WiMAX operator can avoid interference from their own network. WiMAX versus Wi-Fi. WiMAX versus Wi-Fi can't. WiMAX is designed to cover large area, multiple homes/buildings, while Wi-Fi is to cover small area, a home/building. Comparison of WiMAX, Wi-Fi and 3G technology. WiMAX applications: broadband internet multimedia, IP multimedia subsystem, IMS. Cellular alternative. A clear alternative to connect areas without pre-existing physical cable or telephone networks, or just areas without BB access. Broadband internet fixed WiMAX is substitute for T1. Mobile WiMAX has larger coverage than Wi-Fi. WiMAX in UK: Freedom 4S WiMAX license sold for £12.5 million. June 29, 2010. UK Broadband, a subsidiary of PCCW, owned by Hong Kong Telecom, Freedom 4, formerly Pipex Wireless, had the necessary spectrum to launch these wireless networks in the UK, but only Freedom 4 opted to do so with a WiMAX network in Milton Keynes and Stratford-upon-Avon. These WiMAX networks were up and running in real-world situations years before LTE arrived on the scene. http://www.europanetwork.com/WiMAX/. Why did LTE beat WiMAX? UK Broadband's Chief Executive, Nicholas James. http://www.ukebroadband.com/. Most WiMAX backers, including Clearwire in the United States, which has already built WiMAX networks in many US cities, have signaled their intent to move across to LTE. It was never cost-effective for WiMAX networks to compete effectively against fixed-line broadband networks. What happened was that LTE came along early enough so that all operators adopted it, said James. No one adopted 16 meters because there were no economies of scale. Indeed, all WiMAX operators have signaled they will move to LTE. WiMAX is dead as a mobile technology, but it is not dead as a fixed technology. UK Broadband brought Freedom 4S spectrum, because it is adjacent to UKB's spectrum. We now have 124 MHz of LTE, Sprint will kill off WiMAX in 2015. Third-ranked US mobile network Sprint appears to be poised to kill off its implementation of its less-regarded 4G technology, WiMAX. The spectrum it frees up will all move to LTE. http://www.theregister.co.uk/2014/10/06/sprint_WiMAX_2 Number of WiMAX subscriber worldwide from 2010 to 2014, in millions. http://www.statista.com/statistics/27756/. Number of WiMAX subscriber worldwide since 2010/